we are going to start talking about dividing polynomials. We're going to learn about long division today and synthetic division today. To do long division, let me take you back to, I don't know, 3rd grade maybe, when you first started doing long division with real numbers. So let's say that you took, 29, and you divided it by 3. Okay? You'd say, well, 3 goes into 29 9 times. 9 times 3 is 27. So you subtract 27 off, and you had your remainder 2. What this says is your dividend is your 29, the big number. So I could say 29 equals. My divisor is whatever's on the outside, so that's 3, times my quotient, that's whatever's up here, 9, plus my remainder, which is 2. And if you look at it, it's true. 3 times 9 is 27, plus 2 is 29. You're going to be doing that exact same thing today, except for these are going to be polynomials instead of plain old numbers. So here's your steps for long division. And I'm not going to read it to you because it'll make more sense after we do a couple of examples. All right, so it says divide x squared plus 10x plus 21 by x plus 3. So here's my little story for this, okay, for long division. For long division, we are going to be trying to infiltrate a gang, a math gang, a bad math gang. All right, and we're trying to break into their math gang and take them down. Okay, so whatever you're dividing by, those are the detectives, those are the cops. Whatever's getting divided, those are the robbers or the gang. Okay, and the gang lives in this hideout. See, sneaky hideout. Ooh, doesn't it look menacing? Ooh. All right, that's where the gang lives. Alright, so that's going to be the x squared plus 10x plus 21. The cops, of course, are outside. They're trying to get in. Now, they're not just going to knock on the door and go, hey, dude, can I come in? They're going to shoot you. Alright, so what they do is the lead detective was the first guy, and here's the gang leader. Okay, this lead detective's pretty smart. He makes a deal, and he's undercover, and he makes a deal with x squared, and he says, hey, meet me over here in the alley. Ooh, dark menacing alley. So x squared goes, all right, dude, I'll meet you out there. So x squared goes to the alley, my lead detective goes to the alley, and they divide it out, right? They don't fight it out, they just divide it out. So when you divide x squared divided by x, you get x to the first. And that's my first part of my quotient. Okay, it's the first term of my quotient. It's also the code, the secret code that's going to get me and my other detectives in the gang so we can take them out. So to get into the gang, you have to do the secret knock, which is multiply by whatever's up there. So x times x is x squared. You don't want your other cop getting shot, so you give him his disguise too. X times positive 3 is positive 3x. Now, you and the lead detective are in. Alright? Oops. Sorry. Let's change colors there. Alright, you're in. But you can't, what happens is, now that you're in, you draw your guns. So you draw the line, and you pull your guns. See how you took the disguises off, and now they know they're real cops. Alright, and you took out the squared term, which, hey, one is better than none. So now you got rid of him, combine like terms to see what's left. 10x, positive 10x minus 3x is 7x, plus 21 comes down. And you got the gang from 3 members down to 2, so you're taking one out at a time. Okay, so next, again, the lead detective's pretty smart, so here's your new gang leader. And he convinces that guy to go out in the alley. Not the smartest tools in the shed, are they? And they make a division deal. 7x divided by x is positive 7, so that's what goes up. And again, the cops have to do the secret shake, or the whatever you want to call it, their disguise. So x times 7 is positive 7x. Positive 7 times positive 3 is positive 21. But I draw the line and pull the guns, take the disguises off, and x is dead and 21 is dead. Okay, so now we have to write our answer. Well, it says my function, which is x squared, you don't have to write that out, but x squared plus 10x plus 21 is equal to my divisor, which is x plus 3, times my quotient, which is x plus 7, plus my remainder, but in this case is 0. And that would be my answer. And if you multiplied this back out, x times x is x squared, x times 7 is 7x, 3 times x is 3x, 3 times 7 is 21, that's x squared plus 10x plus 21. I get the same thing back. So they are equivalent. Basically, you just factored it by dividing instead of doing our factoring tricks. Okay? Alright, let's try another one. Now your author's a jerk. Here's your gang, all messed up in the wrong order. Alright, so they're going to go into their little layer, but I'm going to write it in order. 6x cubed minus x squared minus 5x plus 4. And I'm dividing that by 3x minus 2. So again, the gang leader, going to the alley here, the gang leader, 6x cubed, meets with the lead detective, 3x, divides it out. 6 divided by 3 is 2. X cubed divided by x to the first is x squared, so that's what goes up. Okay, they got to multiply down to put their disguise on. 3x times 2x squared is 6x cubed. Negative 2 times 2x squared is negative 4x squared. But when I draw the line, change the signs because the guns come out and the cube is dead. Combine like terms, that gives me 3x squared. Everything else comes down, minus 5x plus 4. And we're going back to the alley. We've got rid of one guy. Now we're going to, again, the new gang leader is 3x squared divided by my lead detective, 3x, and you get positive x. So that goes up. And multiply down. Positive x times 3x is 3x squared. Positive x times negative 2 is negative 2x. But when I draw the line, I change the signs, pull the guns, kills the square. Combine like terms, I get negative 3x plus 4. And we got to go back to the alley again. New gang leader, lead detective, is negative 1. So if I put negative 1 up and multiply down, negative 1 times 3x is negative 3x. Negative 1 times negative 2 is positive 2. Draw the line and change both signs, and the 3x cancels, and 4 minus 2 is 2. Okay, so this one did not come out even. In other words, it's not a factor. But we can say that my function is my divisor, 3x minus 2, times my quotient, 2x squared plus x minus 1, plus my remainder. And if you multiplied this back out and combined like terms, you would get this polynomial back. Okay? This would be my solution. Alright. Another one. So here's our gang, right? They gotta go in their secret layer. So we have 6x to the 4th plus 5x cubed plus 3x minus 5. The cops are 3x squared minus 2x. I'm going to go to the alley here. My gang leader, 6x to the 4th, divided by my lead detective, 3x squared, is 2x squared. So I put 2x squared up, And then multiply down. 2x squared times 3x squared is 6x to the 4th. 2x squared times negative 2x is negative 4x cubed. But when I draw the line, I change both signs. The 4th degrees cancel. Add the 3rd degrees is 9x cubed. Bring everything else down. And go back to the alley with my new gang leader, 9x cubed, and my lead detective is still 3x squared, and that will give me 3x. So positive 3x goes up. What goes up must come down. Multiply 3x times 3x squared is 9x cubed. 3x times negative 2x is negative 6x squared. Now be careful here. Draw the line, change the signs, the cubes cancel. These don't line up. You can't add a square to a linear. So you drop it, 6x squared plus 3x minus 5. And we go back to the alley. Oops. And we have 6x squared divided by 3x squared, which would be positive 2. Multiply down. Positive 2 times 3x squared is 6x squared. Positive 2 times negative 2x is negative 4x. But when I draw the line, I change both signs, and the squares cancel, and I add and I get 7x minus 5. Now, I can try and go back to the alley, but if I take 7x, the new gang leader, by my detective, you can't divide an x to the first by an x to the second. So once we can't divide anymore, then whatever's left is your remainder. Okay, so if I write my answer like they want me to, I say f of x, which is this big thing, but I'm not going to rewrite it. I'm just going to say the function is its divisor, 3x squared minus 2x, times its quotient, 2x squared plus 3x plus 2 plus my remainder, 7x minus 5. That would be my solution. Okay? Alright, synthetic division. Synthetic division is a shortcut, but you can only use synthetic division if your divisor, the guy on the outside, has to be a binomial. Can't be 3 terms, can't be 4 terms, it has to just be 2 terms. And the leading coefficient has to be 1, and the degree has to be 1. If any of those things, if it's not a binomial, first degree, leading coefficient 1, you can't do synthetic. You have to do long. Okay, synthetic, I use a zombie story. Okay, so if you look at this example, whatever's inside, okay, your function, whatever it is that you're trying to divide down, all right, you don't write the whole terms, you're just going to write their coefficients. So see how the coefficient of the 3rd degree is 1. The coefficient of the 2nd degree is 4. The coefficient of the 1st degree is negative 5. The coefficient of the constant is positive 5. You just put that in a row and you draw this line underneath it. Now, whatever you're dividing by, in this case x minus 3, okay, you don't put minus 3 in the whole, you put the opposite, positive 3. And that has to do with, you know how when we're doing long division, once you bring it down, you have to change the signs? That's the subtracting. We're changing the sign now, and that takes care of it. Alright, so here's my zombie story. These are the survivors, the 1, 4, negative 5, 5. These have survived the zombie apocalypse. And here, the green is the store that's got their food, and they take turns running to the store, getting food, and bring it back for the next one to eat. So the first one to venture out of their safe haven there, to run to the store is 1. So 1 comes out, runs to the store, multiplies itself by whatever's in there. So 1 times positive 3 is positive 3, and he brings it back, but puts it back in the house. And the next guy in line gets to eat it. So positive 4 eats positive 3, and that makes positive 7, who's now out and runs to the store, multiplies by positive 3 and brings back positive 21 for negative 5 to eat. Negative 5 eats positive 21. Sorry, let's change colors there. And that comes out, just to check, make sure, positive 16. Positive 16 goes to the store, multiplies by 3, and brings back 48 for 5 to eat. Okay, positive 5 eats positive 48, and that comes out 53. Now, that last number is always going to be the remainder. The one in front of it is always going to be the constant. The one in front of that is going to be the first degree. The one in front of that is second in front of that, and it keeps going. So what my answer is 1x squared plus 7x plus 16, remainder 53. So my function, oops, if I'm going to write it in the proper form, my function is equal to my divisor times my quotient. Now your quotient is down here, which is 1x squared plus 7x plus 16 plus my remainder, which is 53. Okay? That's synthetic. Here's another example, and without the storytelling. Alright, so it says use synthetic division to divide 5x cubed plus 6x plus 8 by x plus 2. So if this is my divisor, negative 2 goes in the hole. Now be careful. You notice how there's a third degree and a first degree, but we're missing a second degree? If you don't use zero placeholders, nothing's going to line up right. Remember that the long one we did, and we had an x and an x squared, and we couldn't combine them, so we just brought them both down? Well, here, you're never going to know that unless you use a zero placeholder. So, my third degree coefficient is 5, my second degree coefficient is 0, my first degree coefficient is 6, and my constant is 8. Okay, so I draw the line. First guy out is 5, runs to the store, multiplies by negative 2, brings back negative 10. 0 eats negative 10 and comes out negative 10, who goes back and multiplies by negative 2, which brings back positive 20. Positive 6 eats positive 20, which comes out positive 26, times negative 2. Sorry, let me put it in color. 26 times negative 2 brings back negative 52, and 8 minus 52 is negative 44. That's my remainder. So my function is my divisor times my quotient. Now remember, this is my remainder, this is my constant, so that's x to the first and that's x to the second. So my quotient is 5x squared minus 10x plus 26 plus, in this case minus, because my remainder is negative, my remainder. And that'd be my answer. Alright? Again, they can write it vertically like this. You know, this still means divide. So we have fourth degree coefficient, third degree coefficient, second degree coefficient, first degree coefficient, and the constant. And positive 4 is going to go in the hole. Okay, so 1 comes out, brings back 4, 0 eats 4, comes out 4, times 4, brings back 16, 0 eats 16, comes out 16, times 4 is 64, 0 eats 64, comes out 64, times 4 is 256, negative 256 eats positive 256, wait, 64 times 4, yeah, 256. So this one came out perfect, which means it actually is a factor. And remember that this would be my constant, so this would be my first degree, this would be my second degree, and this would be my third degree. So my function is equal to my divisor times my quotient plus my remainder. Now when the remainder is 0, you don't have to write it, but you can. Alright, so you try this one. And again, you couldn't do synthetic on this one if you wanted to, because again, that would have to be a 1. Didn't have 3 touching x there. So you're going to have to do long division. Hit pause, come back when you're ready, and hopefully you got 3. If you did not, let's look at y. For long division, you put the gang in their secret hideout, negative 15x cubed plus 37x squared minus 8x minus 6. My divisor is outside, 3x minus 5. We go to the alley, and gang leader, negative 15x cubed divided by lead detective, 3x would be negative 5x squared. Goes up. Negative 5x squared times 3x is negative 15x cubed. Negative 5x squared times negative 5 is positive 25x squared. But when I draw the line, I have to change both signs, and the third degree is dead. 37 take away 25 is 12x squared minus 8x minus 6. Gonna go back to the alley. 12x squared divided by 3x would be 4x. So 4x goes up. 4x times 3x is 12x squared. 4x times negative 5 is negative 20x. But when I draw the line, I change both signs. The squares cancel. Negative 8 plus 20 is 12x. Bring down to minus 6. Back to the alley. 12x divided by 3x is positive 4. Goes up. 4 times 3x is 12x. 4 times negative 5 is negative 20. But when I draw the line, I change both signs. The 12x cancels, and I get a remainder of 14. So my function will be my divisor times my quotient plus my remainder. Now you're going, what the heck, miss? Why did they write it like this? I'm sorry, I didn't realize that they were going to do that to us. This is what we call fraction form. It's the same as, remember when the original I did, 329 went 9 times, take away 27 was remainder 2? You remember when we could also write the answer as 9 and 2/3? Because you took your remainder and put it over your divisor. That's all they're doing. You can write the function, you can write f of x divided by d of x is my quotient, negative 5x squared plus 4x plus 4, plus my remainder over my divisor. It's just a different form of writing it. This is called, I don't know what this one's called. This one's called fraction form. Oops. Yeah. Okay. Sorry. Alright. You try this one. Hit pause. Come back when you're ready. And hopefully you got number 2. If not, okay, we've got our nasty gang in here. Negative 4t to the 4th plus 18t to the 3rd plus 8t to the 2nd minus 60t minus 40. My divisor is 2t squared minus 4t minus 4. Going to the alley. I have negative 4t to the 4th divided by 2t squared is negative 2t squared. So that goes up. Negative 2t squared times 2t squared is negative 4t to the 4th. Negative 2t squared times negative 4t is positive 8t cubed. Negative 2t squared times negative 4 is positive 8t squared. When I draw the line, I have to change all signs, and the 4th degrees cancel. 18t cubed take away 8t cubed is 10t cubed. Oh, Merry Christmas. The squares cancel. Minus 60t minus 40. and I gotta go back to the alley. So I have 10t cubed divided by 2t squared is going to give me 5t. Goes up, multiplies down. 5t times 2t squared is 10t cubed. 5t times negative 4t is negative 20t squared. 5t times negative 4 is negative 20t. And I'm going to draw the line and change all signs. The cubes cancel. Now, this square doesn't have a square to line up with, so it comes down. And then I can combine my t's. Negative 60 plus 20 is negative 40t, negative 40. And I'm going back to the alley again. 20t squared divided by 2t squared is 10. So positive 10 goes up. 10 times 2t squared is 20t squared. 10 times negative 4t is negative 40t. 10 times negative 4 is negative 40. But when I draw the line, I have to change all signs. Everything cancels. My remainder is 0, so my quotient is negative 2t squared plus 5t plus 10. Alright, this one they want you to do synthetic division. So hit pause, come back when you're ready, and hopefully you got 1. Alright, to do synthetic, you put negative 7 in the hole, your second degree coefficient, first degree coefficient, constant. 1 comes out. Times negative 7 is negative 7. 16 eats negative 7, comes out positive 9. Positive 9 times negative 7 is negative 63. Positive 61 eats negative 63, comes out negative 2. That's my remainder, that's my constant, that's my x to the first. So my answer is x plus 9 minus 2 over the divisor. Okay. Alright, try this one, synthetic. Watch your missing degrees. Hit pause, come back when you're ready. And hopefully you got 2. Alright, my positive 2 would go in the hole. My fourth degree coefficient, third degree, second degree, first degree, and constant. So 1 comes out, brings back 2. 2 comes out, brings back 4. 4 comes out, brings back 8. 8 comes out, brings back 16. And 32 comes out, which has to be my remainder, which that would be my constant. That would be my first degree. That would be my second degree. And that would be my third degree. So my answer is x cubed plus 2x squared plus 4x plus 8 plus my remainder over my divisor. Alright, so how do you divide using long division? You need to describe that in your own words, short and sweet as possible. Same with synthetic division. I don't care if you use the stories, the cops and robbers, the zombies, however you want to explain those. When is it appropriate to use synthetic division? When your divisor is a binomial with leading coefficient 1 and highest degree 1. Otherwise, you have to do long. How do you divide when the dividend has missing terms? You use 0 placeholders. Alright. The remainder theorem. The remainder theorem says if the polynomial f of x is divided by x minus c, then the remainder is f of c. What it says is if you did either long division or synthetic division, when you get your remainder down here, it will always be the same number as if you just did f of c. In other words, if you took your function and changed all of your x's to that number. Alright, so let me show you. It says, given that f of x equals x cubed minus 4x squared plus 5x plus 3, use the remainder theorem to find f of 2. If I find f of 2, substitution. That means take your function and replace all of your x's with 2's and simplify. This would be 8. This would be minus 4 times 4. This would be 10 plus 3. That'd be 8 minus 16 plus 10 plus 3. That'd be negative 8 plus 10 plus 3. That'd be 2 plus 3 is 5. Or you could just type in the calculator. So f of 2 is 5. What do you do? What does that tell you? Well, what it means is, look, if I was doing f of 2 and I did synthetic division, that means put 2 in the whole. My third degree coefficient, second degree, first degree constant. 1 comes out, brings back 2. Negative 2 comes out, brings back negative 4. 1 comes out, brings back 2. And sure enough, my remainder is the same as when I just did direct substitution. And that's the remainder theorem. So what's cool about it is if they don't have any interest in what the quotient is, in other words, they just want to know what the remainder is, you don't have to do long division or synthetic division. You can just substitute the 0 in and see what the answer is. Alright, so it says use the remainder to find f of negative 4. You literally copy your function and you replace all of your x's with negative 4's. And if I take a negative 4 cubed, I get 3 times negative 64 plus 4 times positive 16, positive 20, positive 3. These two, that's negative 192 plus 64 plus 20 plus 3. And I'm just going to type it all in now, left to right. And we get negative 105. And what that means is, if I were to do synthetic division, I get a remainder of negative 105. What that means is that this is not a factor. If it's a factor, your remainder is 0. Alright, so find f of 3 here, hit pause, come back when you're ready. Hopefully you got 1. If I find f of 3, I'm going to have 6 times 3 to the 4th plus 2 times 3 cubed plus 3 times 3 squared minus 4 times 3 plus 40. Ugh. 3 caret 4 is 81. 3 caret 3 is 27. 3 caret 2 is 9. Negative 12 plus 40. 6 times 81, 486, plus 54, plus 27, minus 12, plus 40, and then I'm just going to type it, 486, plus 54, 27, minus 12, plus 40, and you get 595. Alright, don't let the fraction freak you out. Use a calculator, hit math enter when you're done. Hopefully you got 4. So I have f of negative 1 4 to the 4th, to the 3rd, to the 2nd, to the 1st. Okay, so if I plug in negative 1 4 there, and I would just type it all in a calculator and hit math enter when you're done. I mean, I could do the math, but if I type parentheses, negative 1 divided by 4, close your parentheses, caret 4, math enter, that gives me 1 over 256 plus 8 times 1, negative 1 over 64 minus 2 times 1 over 16 plus, that's going to be negative 4 over 4, so that's going to be negative 1, and then minus 5. And then if you type this in left to right and math enter it, you get that. Alright, so explain the remainder theorem. F of some number will give you the same remainder as if you took that number and either did synthetic or long. Okay? And we are at homework, so we are done. Happy homeworking, and I will see you next time.